Okay, so today's lesson is a lesson about predicting products. And in the past, we have predicted products for single replacement reactions, double replacement reactions, synthesis, decomposition, and and combustion reactions. And so today we're going to still focus on some of those reaction types, but one very specifically. And so one of the things that we need to do is we need to talk a little bit about some important vocabulary first. So the very, very first piece of vocabulary that we are going to talk about is the word or phrase soluble. When we say that a substance is soluble, it is a substance that is able to dissolve in water. And when we say something is able to dissolve in water, what state of matter are we often referring to when we say that you have something dissolved in water? Yeah, we're talking about an aqueous substance, which we often designate as the AQ. Now, if I wanted to draw what this would look like, so I might have something like a substance that's dissolved in water, like maybe a circle and like another circle. And then I might have like, I don't know, let's just say maybe a square and another square. And if it's dissolved in water, we would just simply say that it is surrounded by water, right? So, and the X's, as you might recall, show that they are surrounding those substances by water, right? If something is considered to be insoluble, it's a substance that does not dissolve in water. And in chemistry, something that doesn't dissolve in water, we will oftentimes refer to as just being a solid. So that's your S, right, for its state of matter. And so if I wanted to draw something that does not dissolve in water, I would draw something that looks maybe like this. Where they're bonded together, they're a solid, they're organized, and then we would just have our water surrounding it. Okay. And then sometimes we also have another term that we're going to talk about that's called a precipitate. And a precipitate is when you have a solid that forms as a result of a chemical reaction. So this is a solid that forms as a result of a chemical reaction. Okay, so that's a solid that forms as a result of a chemical reaction. So those are three terms that we're going to be using over the course of the today and tomorrow and a big chunk of next week. So we're going to kind of continue to use those, and I just wanted to define those first. Now we're going to talk about the actual sort of meat of today's lesson, which is solution phase reactions, which, as you might remember from like a long time ago, is a special type of reaction called a double replacement reaction. And in a double replacement reaction, we're talking about like A reacting with X, or AX reacting with something like B, Y to produce A, Y, and B, X. Right? You might remember like that situation where the reactants parts switched places with one another. And in a solution phase reaction, what we're really talking about is the products of these types of reactions. So if I quickly illustrate what I'm getting at here, this would be like A, and then A, and then X, and then B, and then Y. Okay. All right. So in solution phase reactions, the fact that the word solution is in the name or the concept or the content should tell you that your reactants are going to be aqueous. So in both instances, the reactants are going to be aqueous. It's what happens on the product side that determines whether or not a reaction will occur. So a reaction with two reactants and two aqueous products is considered as not reacting, or more specifically, we would say no reaction occurs. You could also just write no RXN because that's shorthand for reaction. In a reaction which has two aqueous reactants and an aqueous product and a solid product, we can say that the reaction occurs. Okay. So these two scenarios are going to be really important for how you proceed with the rest of today's lesson. If you have aqueous as a product, then you are going to have no reaction. And if you have aqueous solid, or for that matter, solid aqueous, you will have a reaction that occurs. So let's take a look at an example. Here we have a fancy example that's already been done for you. I've already had my reactants my reactants. They're set up. We know their state of matter. The reactants' state of matter are both aqueous. We have two products that we don't know the state of matter yet, but they've already switched around. This reaction happens to be balanced as it's written. So there's a lot of great things that are going on here. Now, what we have to do is we have to use the solubility rules to predict our products. Okay. So our solubility rules, this yellow slip of paper that I've given everyone, are the key to identifying whether or not the reaction will occur. So you really need to focus in on what I'm about to do, which probably means you don't need a cell phone for that because this is important. So these rules right here are designed to be statements of truth. Okay. If you read the rule and it's true, then that tells you something about that product. If you read the rule and it's false, then you move on to the next rule. And if that rule is false, then you move on to the next rule. And if that rule is false, you move on to the next rule until you find a rule that is true. So I'm going to focus on KNO3, which is the first product. And if I read the rule for if I read the rule number 1, right here on this yellow slip of paper, it says compounds that are made with ammonium, NH4, and group 1 metals, which are lithium, sodium, potassium, rubidium, cesium, francium, the ones in the first column of the periodic table, are considered soluble. So in this case here, the letter K, the element potassium, is a group 1 metal. So that means that rule number 1 is true, and it says that they're soluble. So if they're soluble, that tells me that this product has to be aqueous because of rule number 1. So now I know the state of matter for the first product. So now I'm going to focus on the second product. Okay. So the second product is AgCl, and I'm going to start with rule number 1 again. Rule number 1 says salts of ammonia with NH4 plus and group 1 are always soluble. Remember, group 1 is lithium, sodium, potassium, rubidium, cesium, francium. And since None of those are present in AgCl. We are going to skip to rule number 2. Rule number 2 is a rule that talks about chlorides, chlorine, bromides, bromine, and iodides, iodine. This compound happens to have a chlorine in it, so I'm going to read that rule. All chlorides are soluble except if they're paired with Ag, silver, Hg, mercury, and Pb, lead. So in this case, because chlorine is paired with silver, it is soluble except, which means it's insoluble. So that tells me that because of rule number 2, I have a solid because of rule number 2. Yes. The question is, do you have to memorize this list? The answer to that question is no, you do not have to memorize this list. You will be given it. You just need to know how to use the list. So that's half of the battle. Okay. Now, the next thing that you have to do is you have to write something called the net ionic equation. And to discuss the net ionic equation, I like to give you this example here. So here's the deal. You're walking down the hallway with your posse, your clique, your entourage, your peers, your friend group, I don't even know. And down at the other end of the hallway, you see your nemesis. Okay. And you're like Perry the platypus. And you're like, what are you going to do about it? And then your friends are like, I bet you won't stick him. Or your girlfriends are all like, you should go slap that wonderful human being. And so you go down there and you go, and as you're getting closer, your friends are all like, do it. They wronged you. Do it. So you go over there and you just start pummeling said human being. Okay. And you're getting into a nice bit of fisticuffs, if you will, that ends up with you two on the floor doing one of those weird wrestling roll-arounds. No, I don't have to fight. Now, the issue is this. So if that argument, that fight, that interaction has you and this person on the floor and you are engaged in a sticky situation. What are your peers, friends, entourage doing? They have whipped out their cellular device and they are now recording and they are viewing. What's a word that starts with S that says that you are taking in something? Spectating. Okay. So there is a part of this scenario where the reaction is actually occurring, and that reaction that's actually occurring isn't all of the parts of the chemical equation that's written up here, but what it really is in reality is you have some individual parts of the chemical reaction that are spectating, and then you have some that are actually participating in the reaction. And so if a solid is formed, according to this information up above, when a solid is formed, the reaction occurs. The reaction is like a fight. So when we write the net ionic equation, the net ionic equation is the equation for the ions that make the solid. And when I write my net ionic equations, I usually write them backwards first. So I start with the product. And in this case, the product is going to be silver, chloride, and I know it's a solid because my solubility rules told me that. So now I'm going to go back into the original reaction, the original equation, and look for where chlorine is, and I'm going to look for where silver happens to be. And so I'm just going to bring those two down as they're written. So I'm going to bring down the chlorine, and I'm going to bring down the silver, and I'm going to say that they are part of a reaction. And I know they're states of matter, right? Because chlorine is aqueous and silver is aqueous, right? And then the last thing I have to do is I have to know that they're ions. And because I know they're ions because they are there's a metal present, so it's an ionic compound, and it's dissolved in water. And so I go and I grab my handy dandy periodic table, and I see that chlorine, I lied, chlorine is over here. Chlorine is in group 17. It happens to be element number 17. If you recall that column always has a charge of a -1. Silver is element 47. It's in the middle of the periodic table. But at one point or another, we told you to write the charge of silver down, and it's a +1. So that is your net ionic equation. It's the ions that form the solid, and this one happens to be balanced because it's like 1, 1, 1, right? And then the last thing you have to do is you have to identify who the spectators were. And in this case, the spectators are the ions that are still aqueous in solution after you've identified the solid. So that means that it's going to be a potassium ion and it's going to be a nitrate ion. Now, the nitrate ion is a little bit easier to figure out because that's a polyatomic ion, and so that's on the back, and we know that the charge of that is a -1. And potassium is a group 1 metal, right? It's a group 1 metal, which means that it's going to have a charge of +1. And that's what you have to do. And I realize that for some of you, like, that's a lot. But we're not afraid of a little hard work in this chemistry class. We can roll up our sleeves and get a little dirty. It's okay. So we're going to roll on and keep doing or trying out example number 2. So just to kind of get this started, I'm going to throw down my template here because I think that that's kind of important. Because that helps, I think. And then I'm going to match up the elements with the letter in the template. So under A, there's Na or sodium. So I'm going to put that on my product side. On my reactant side, under Y is Cl. So on the product side, I'm going to also put Cl. And on the reactant side, under B is calcium. So I'm going to put Ca. And on the reactant side is PO4 under X. So I'm going to put that like so. Now, you might recall from when we talked about balancing chemical equations and predicting products from once upon a time, a long time ago, that I would say to you to check your charges. And that's the next step that we have to do here. So I'm going to put sodium, and I know that sodium is a group 1 metal. It's in the first column, which means it has a charge of +1. And I know that chlorine is a group 17 nonmetal, and a halogen, and I know that it has a charge of -1. And when I crisscross those charges down, I get Na1Cl1. And so I always check my ratio to see if I can simplify it. And in this case, a 1-to-1 ratio, I can't simplify. So I'm going to leave my formula as is, NaCl. Calcium is a group 2 metal. It's in the second column, so it happens to have a +2 charge. PO4 is a polyatomic ion, which on the back of the periodic table has a charge of -3. And when I crisscross those charges down, I get Ca3PO42, which tells me I should probably check my ratio to see if I can simplify. And in this instance, the 3-to-2 ratio cannot be simplified. So I'm going to bring that down as subscripts for my calcium and phosphate compound. Okay. Now what I'm going to do is I'm going to, I guess I could go ahead and prepare to balance this thing. So why not? I know from personal experience and the fact that I've done it like 4 times today, how to balance it. And I'm going to speed this process up for us. So I'm going to throw a 2 here and a 3 here and a 6er there and a 1 there just to make our lives a little bit faster today. So that's a lot of work, but we're not done yet. And I believe that we can handle it. I would not ask you to do something I don't think you can do. So now we have to consult our solubility rules. Okay. Our solubility rules, we start with the first product. So I'm going to start with NaCl. And I'm going to look at my rules and I'm going to look for something to be true about them. The first rule says salts of ammonium, NH4, and group 1 are always soluble. Remember, group 1 metals are lithium, sodium, potassium, rubidium, cesium, francium. And it looks to me like there's a group 1 metal, which happens to be sodium, and this rule says they're always soluble. So if they're always soluble, that tells me that this is going to be aqueous because of rule number 1. So now that I know the state of matter of NaCl, I can now focus in on the state of matter of Ca3PO4. And I'm going to start back at rule number 1, which says salts of ammonium and group 1 metals are always soluble. And in this case, a group 1 metal would be sodium, lithium, potassium, rubidium, cesium, francium, and none of those are present. So then I'm going to focus on rule number 2, which talks about chlorine, chlorides, bromides, bromine, or iodides, iodine, and none of those are present in the second compound. Then it's going to talk about chlorates, ClO3, nitrates, NO3, and acetates, C2H3O2. Those are also not present. Then it talks about sulfates, SO4, and I do not see an SO4 here. So now I need to continue on to rule number 5, and rule number 5 talks about phosphates, PO4, carbon and carbonates, and it says that they are insoluble except if they're with NH4 and group 1 ions like lithium, sodium, potassium, rubidium, cesium, francium. And since that's not present and it tells me that it's insoluble, that means that this is a product that forms a solid because of rule 5. And so according to the information that we have above, right, so I'm going to scroll back up to take a look at this real quick once. If I have an aqueous product and a solid product, the reaction occurs. So that tells me that this is going to be, I can identify this as reaction occurs. So now, because the reaction occurs, I need to write my net ionic equation. And I need to identify my spectator ions. And so just like I did last time, I'm going to start with the solid product first. So I'm going to write Ca3PO4 and I know it's a solid because we've already identified that because of the solubility rules. The next thing that I'm going to do is I'm going to go ahead and try to identify the ions that make that solid up. So I know that one of those has to be calcium and one of those has to be phosphate. I also know, so I'm going to write them as they appear. So I'm going to have PO4. And because we've already done a little bit of work, I don't have to check anything. In the top of this slide, in the top of this picture, I see that I have a PO4 that has a charge of what? What's its charge? -3, right? So it has a charge of -3, okay? And I also know its state of matter, which is aqueous. Calcium, I'm going to bring that down. And because we've done a little bit of prep work, has a charge of what? Has a charge of +2. And because of how it's written as a reactant, I know that that one is aqueous as well. So now I have to go back and do some balancing. And going from left to right, the PO4 on the left-hand side, the reactant side, there's only one of them. And on the product side, there's two of them. So I'm going to need a coefficient of 2 here. Calcium on the left-hand side, the reactant side, there's only one of them. And on the product side, there's three of them. So I need to put a coefficient of 3 here. And then this becomes a 1. And then the last thing I need to do is identify my spectator ions. That is the ions that are aqueous as products. And so in this case, that's going to be Na, which we identify as a charge of +1. And it's going to be Cl, which we can identify as a charge of -1. That's that. Now, I know this feels like a lot, but it's not as bad as it seems. So we're going to move forward. We're going to do a couple examples today. We've already done a couple, so now we got to do a second couple. Example number 3. Just like before, we have AX reacting with BY to produce AY and BX. I'm going to match up the things that I have here. So under A, I need to put an Na for sodium. And under Y, I need to put a Br for bromine. Under B, I need to put an Li for lithium. And under X, I need to put an NO3 for nitrate. Now, just like we did earlier, we need to identify our charges for all of these. So sodium, Na is a +1 because it's in the first column. Okay. Bromine, Br, is a -1. We crisscross those charges down. Bromine's a -1 because it's in the 17th column. I'm going to check the ratio. And I see that it's 1 to 1. Can't simplify that, so I'm going to leave NaBr as it is. I need to check my second compound. So I have lithium, which is in a group 1 metal, so it's a +1. And I have nitrate, NO3, which is a polyatomic ion, and I found on the back of my periodic table it's a -1. So when I crisscross those charges down, I get Li1, NO3, 1. Our ratio here is 1 to 1. And I don't have to simplify anything there. And so in this instance here, I can go ahead and look and see, there's one. It's pretty much balanced as it is. So it's like a 1 and a 1 and a 1 and a 1. But now we need to consult our solubility rules. And we're going to start with solubility rule number 1, just like we did before. So solubility rule number 1 says, salts of ammonium, NH4, and group 1, lithium, sodium, potassium, rubidium, cesium, francium, are always soluble. So that tells me, because of rule number 1, that first product has to be aqueous. So now I'm just going to go on to the second compound and start at the same spot. Salts of ammonium and NH4 and group 1 are always soluble. Okay. So group 1, remember, is lithium, sodium, potassium, rubidium, cesium, francium. So that means this one is soluble because of rule number 1. Both of them. Rules can be used more than once. So if I go back up to the top of the notes here, which I'm going to come back to in a second, if you have an aqueous product, what does that tell you about the reaction? There's no reaction, right? So that tells me that I can simply go and say no reaction occurs. Or you could just write no reaction. So in terms of net ionic equations and spectator ions,
how did you know it was a no reaction?
So if I go back, the question is, how did I know it was a no reaction? So if I go back up to here, the very, very first bullet point that I'm looking at says a reaction with 2 aqueous products, aqueous is considered as not reacting.
Oh, okay.
Okay. So now I'm down here, and because it's not reacting, I don't have to write a net ionic equation. But I do have to identify what my spectator ions are, which in this case are basically all of them. So I have Na, which is a +1. I have NO3, which is a -1. I have Li, which is a +1. And I have Br, which is a -1. Okay. So there's one more example. This is a U-try. Give it the old GHS try, people. All right, we're going to go on to the next one. Go ahead and give this one the old GHS try. You can do it. I believe in you. Ready, set, let's go. Okay, so I've put up here my work for the products. If you're there, great. If you're not quite there, that's okay too. The other thing you need to do is start focusing on whether or not this reaction occurs by using your solubility rules. So hopefully you were using your rules and you got all the way down to solubility rule number 7. Solubility rule number 7 tells you that hydroxides are insoluble except if they're paired up with a bunch of atoms. In this case, that one happens to be calcium. And then rule number 1 tells you that lithium sulfate is soluble. So you have an aqueous product, which means you have no reaction. You do not have to write the net ionic equation in this case, but you do have to list the net or the spectator ions, which in this case are calcium, sulfate, SO4, lithium, and hydroxide, OH. Okay. So that's how we work with predicting products of double replacement reactions. Good luck with this tomorrow.